We're going to now look at solving trig equations. So in your book, this is 7.2. What I want to do is simply list 5 or 6 or 7 different equations that we're eventually going to solve in this video, just to give you an idea of the kinds of equations we'll be solving. And then let me talk about how we go about solving them. So of course we'll start with the simpler ones, simpler looking ones, and go to more difficult. So for instance, here's a fairly straightforward trig equation. Sine of theta equals negative square root of 2 over 2. Now actually, let me talk about this for a minute before I list the rest of the equations, because up until now we have learned about trig functions, and what we basically have always done was we were given an angle and then we found the trig function. In other words, we were told the angle is pi over 2, and we were told what is sine of theta. Well, we know that sine of pi over 2 is 1. Or say I had an angle of 3 pi over 4, and I said, what's the cosine of 3 pi over 4? And hopefully now that you're becoming experts on the unit circle, you realize, you think to yourself, what's the cosine of 3 pi over 4? It's in the second quadrant, that middle point, and you realize it's negative square root of 2 over 2. Or what's the tangent of (11 pi over 6? Once again, using the unit circle, in my mind I go figure out where 11 pi over 6 is, which is there in the fourth quadrant. Of course, I tell myself tangent is sine over cosine. So I go to that point and I realize that 11 pi over 6, the sine is negative 1/2. The cosine is square root of 3 over 2. So the tangent of 11 pi over 6 is negative 1 over square root of 3. So up until now, we were given angles, and we found trig functions. Now we're sort of flipping that around, because look here. We're being asked to find the angle. Here we were given angles, now we're actually trying to find the angle. And that's basically what we're doing when we solve these trig equations. So now let me just list the rest of these. So for all these trig equations, basically it's always going to be you're solving for the angle. It's like the angle is your variable. You're trying to decide, you're trying to find a value for theta that makes this equation true. Now, since we're working with angles, of course, there's 2 possibilities. You can either have the answer in radians or degrees, and you have to look for each problem and see what they require. My hunch is most of the time we're going to be doing them in radians, but there may be an occasional problem where they ask for the solution in degrees. We can do either one. So once again, this is a trig equation. We're trying to solve for the angle. Here's another one. These first few don't look too complicated, and when we get around to solving them, they're actually not that complicated. So all three of these, we have our trig function, we have our angle theta, and then we have a value. So for each of these, solving these equations means finding the angle that's going to make each one of these equations true. Now here is a little twist, and when we go about solving this one, you'll see how it affects what we do. Instead of having just theta inside the trig function, now we have 2 theta. And you'll see in a little bit what we have to do to go about solving this kind of trig equation. And even a little more complicated, cosine of 4 theta minus pi over 4 equals square root of 2 over 2. So here we have the trig function cosine, but inside the cosine, it's 4 theta minus pi over 4, and that whole thing has to equal square root of 2 over 2. Ultimately, when we solve this equation, we're still trying to determine the value of theta that makes this equation true. And just so you know, with these trig functions, it's very possible there might be more than one solution. Matter of fact, for most of them, there are more than one solution. And we'll see that in a little bit. And then there are a couple more. So now they're getting even a little more complicated, and even when we look to solve them, we'll have to do some different things. Okay, this is interesting. Sine theta times tangent of theta equals sine theta. Up until now, we've only had equations with one trig function. Now, if I look at this one, I actually have 3 trig functions. Of course, they all have a theta inside. Eventually, we're going to solve that equation for theta. In other words, let's go find an angle that when I put that angle in here for these 3 thetas, the equation works. And then we'll do one more. 2 sine squared theta minus cosine theta minus 1 equals 0. All right, so these are all different kinds of trig equations that we're going to solve. So let's just start with the first one and explain sort of the principles and the ideas, and then once we start there, I think the rest of them, it'll just build and not be too difficult. So let's start with that first one. Now let me explain that in solving these trig equations, it's going to be a 2-step process. The first step is when you have an equation, especially the equations with only one trig function, the first step is to isolate the trig function. So this really applies to these first, until the problems with multiple trig functions, then this doesn't apply as simply. It does, but it's not as clear. But for all these equations where there's just one trig function, the first thing we have to do is to get that trig function by itself on one side. And then once you get the trig function by itself on one side, then we have to look and actually solve for the actual angle. So it's really a two-step process. You're going to have to do some math or some algebra to get the trig function by itself. And then once the trig function's by itself, then you can go in and determine the actual angle, which will be your solution. Now for this first problem, the trig function is already by itself. It was given to us that way. So there's nothing here to do. So here's what we do now. Here's the question I have to ask. And let me write this question out, because this is the question we're going to ask over and over again as we're solving these trig equations. For what angle theta, so I'm looking for an angle, for what angle theta, let me put it like this, for what angle, which we're talking about theta, for what angle will the sine of that angle equal negative square root of 2 over 2. So let's think about that. What I'm saying is, I'm trying to solve for theta. I'm trying to find an angle for theta that when I take the sine of it, it's going to equal negative square root of 2 over 2. So basically I'm saying I need to go find an angle where the sine of the angle is negative square root of 2 over 2. You know what I'm going to do? I'm going to use the unit circle. Hopefully you've all got it memorized by now. So you ask yourself, okay, you think of the unit circle. Now I'm looking at the sine, so I think to myself, where on the unit circle, for what angle is the sine negative square root of 2 over 2? So I'm looking at my points around the unit circle, and I'm really looking for where is the y value of a point negative square root of 2 over 2. Well, right away I realize, oh yeah, the square root of 2 over 2, those are all those pi over 4, 3 pi over 4, 5 pi over 4. Those are the sort of the middle points in each quadrant. And I ask myself, so where, what are the angles where it's negative square root of 2 over 2? Well, where is the sine negative? The sine is negative in quadrants 3 and quadrants 4. And I say to myself, sometimes I even draw the unit circle. I know that this point right here, the sine of that point is going to be negative square root of 2 over 2, and that angle right there is 5 pi over 4. But you know what? There's another point on my unit circle that also gives me negative square root of 2 over 2, right here. 7 pi over 4. There are actually two angles that will solve, in other words, sine of pi over 4 equals negative square root of 2 over 2, but also the sine of 7 pi over 4 equals negative square root of 2 over 2. So there are actually two angles. Now this is one trip around the unit circle. There are two angles that could be solutions. So I could say my solutions would be theta could be 5 pi over 4 or 7 pi over 4. All right, so hopefully you see that. So once again, to solve this trig equation, I'm going to go find an angle that when I go take the sine of that angle, that equals negative square root of 2 over 2. So basically what I do is I go to my unit circle and I say, let me go find all the points where the sine is square root of 2 over 2. And as it turns out, there are 2 points right here and here. So hopefully that makes sense. But you know what? We're not really done yet. Because you know what? I'm looking for all the angles that will make this equation true. And I found 2 angles, but you know what I did? I went around the unit circle once. But what would happen if I decided to go around the unit circle once and then started to go around it again and stopped here at 5 pi over 4? In other words, how about if I look at the angle 2 pi plus 5 pi over 4? If I change this to 8 pi over 4, actually, so if I go around the unit circle once, that's 2 pi, and then I stop here, I'm at 13 pi over 4. What would the sine of 13 pi over 4 be? You know what it would be? Negative square root of 2 over 2. So you know what? I've actually got a third angle that's a solution. And I could do the same thing. If I look here at 7 pi over 4, if I went around the circle once and then went around again, I could say, well, you know what? My solution is 2 pi plus 7 pi over 4, which is 15 pi over 4. That's another solution because the sine of 15 pi over 4 is negative square root of 2 over 2. As a matter of fact, do you know how many solutions there actually are to this equation? There are an infinite number of solutions. And why is that? Because you can just keep going round and around the unit circle. So here's how we really need to write the solution to this equation. It's like there are 2 possibilities. You got all the angles that end up here at 5 pi over 4, and then you have all the angles that end up here at 7 pi over 4. So what I can say is my actual solution should be, I'm going to write the 5 pi over 4 first, and then let me write this out and explain to you why this works. Plus 2 pi times n, where n equals 0, 1, right here, n equals 0, 1, 2. N is like an integer. It's just a number that keeps increasing by 1. So what is this saying now? My solution is going to be, you take 5 pi over 4, and what you do first is you set n equal to 0. So when n is 0, my theta is 5 pi over 4. And that's a solution. But we know there are more than just one solution. So now what I'm going to do is I'm going to set n equal to 1. And when I set n equal to 1, I'm going to have 5 pi over 4 plus 2 pi, which is what we talked about down here. So when n is 1, my angle is 13 pi over 4. And then I could keep going forever, where I just keep bumping up my n, and I create a new angle here, but the sine of the angle is still going to be negative square root of 2 over 2. So if I put n equals 2, this is 4 pi 16, I think it's like 21 pi over 4. You know, the sign of 21 pi over 4 is the negative square root of 2 over 2. These are all solutions. But the way we write it is like this to make it very compact. So whenever you see this 2 pi times n, even though we're not going to write this all the time, basically you know what this means is n can either equal 0, it can equal 1, it can equal 2, it can equal 3, it can equal 4. Matter of fact, this n would go on to infinity, and that's why there's an infinite number of solutions. But you know what? This is the equation for the 5 pi over 4, but I can do the same thing with the 7 pi over 4 angle. So I start out by writing 7 pi over 4, and then once again I add on this 2 pi times n, because once again all this does is it keeps going around the unit circle and landing at 7 pi over 4, and that's going to be a solution to our equation. All right, so that explains the idea of solving these trig equations. You're going to go find the angle or angles of your solutions, but then you have to realize that there's actually an infinite number of angles. Now I'll explain in the next video what they'll do sometimes. They'll give you an equation, but they'll say, but only give the solutions where the angles are between 0 and 2 pi. In other words, they're saying we don't want to know every possible angle that's a solution. Just give us the ones that's between 0 and 2 pi. You know what they're really saying? Just give us those solutions that you find in one trip around the unit circle. So that's what they like to do sometimes. In your homework, in some problems, they want this right here. They will want the equation for all possible angles. But then in some other problems, they will tell you, for your solution, just give the angles between 0 and 2 pi. And then you just, like for this problem, if they had asked it like this, my solution would have been 5 pi over 4 and 7 pi over 4. In other words, those are the only two angles that are between 0 and 2 pi. All right, so that's a good start. So let me go, and I'm going to create another video, and then we're going to start working through the rest of these equations, and hopefully you'll get the hang of it quickly of how to solve these trig equations.